great place to be, and great to connect with the entire rail industry, because we've got a lot in common, and we've got a lot that of potential opportunity for that industry as well. I would like to give you all a warm welcome to the world of Hardt Hyperloop, where it's basically our vision that we create a world where you can travel over an entire continent with the Hyperloop in the same way that you now travel with a metro through a city, and at the same time that the entire continental supply chain is connected within several hours, really turning it into a single market. The main message I want to give to you today is, I think, similar a little bit, that's echoing what Andres also said, is that Hyperloop is actually a way in which you can save infrastructure investments. It's not just something that's completely new infrastructure that we have to invest in. It's more like, how do we repurpose existing infrastructure budgets into something that will bring us a much more benefit. If you look at the demand of transportation, it's expected to grow by about 250% by 2050. It is expected that we will need about 50 trillion euros of investment worldwide to accommodate this growth. About 50% of that is lost to maintenance or marginal improvements to existing systems. What we are looking for with Hyperloop is, can we provide a solution that uses just a fraction of the investment that is needed anyway, but then provide an infrastructure that provides a high amount of capacity, with low energy usage, with no noise, with low uses of space, and generally integrating much better with the other modalities to provide a real modal shift to sustainable mobilities. So we've all been talking about Hyperloop already, but I don't think we quickly went through the main systems of it, so let me quickly take you through it. Of course, the main aspect is that there's a low pressure environment in a tube, which means about 10 times lower energy usage than aviation or road transport. The tube isolates from the environment, so that means no wind, rain, snow, no leaves on the track, making the system relatively reliable. It's also driverless, meaning that you can run it autonomously, but also that it reduces the amount of drivers needed, which is a huge aspect of the driver shortages that we're having and becoming more and more over the time. The vehicles are magnetically suspended and guided, which means that you never touch the track, so that means low maintenance costs, which helps with saving those infrastructure investments. But also, you have quite a big air gap, so that means that the infrastructure doesn't have to be as perfectly straight as, for example, high-speed rail. And finally, as sort of a cherry on the pie, there's a magnetic lane switch, which allows you to go from one tube to another without any moving components in the track. So typically in rail, it's the rail that decides where the vehicle goes. But in Hyperloop, you can make it such that the vehicle decides where the vehicle goes, where the track is entirely static, and the vehicle either pulls itself with its magnet to the right or pulls itself with its magnets to the left. What this allows is that you can have a main line where you go at very high speeds, but you can have on and off ramps which allow you to connect many cities, neighborhoods across the corridors. What this allows is that you don't only have a very high speed line connecting far away countries, but you could, for example, have a short network in Randstad in the Netherlands where you connect Amsterdam, Rotterdam, Utrecht, Den Haag, all within about 15 minutes. Same in the Rhine-Ruhr-gebiet, where you can connect Düsseldorf, Bonn, Köln, and so on within about 15 minutes. But then you draw a line through these regions, and you connect Randstad and Berlin within about an hour, and at the same time connecting places like Hamburg, Paris, Frankfurt, and Warsaw, all within a range of about 2 hours. So it completely changes the way in which we can plan our cities, countries, and all of Europe. You can connect with transport cargo and passengers in one system. You can connect directly into city centers, making it very close to where you want to live or where you want to go. You can connect new neighborhoods, for example, new development zones, thereby reducing the pressure on the housing market in the more economically powerful zones. You can directly connect to airports, which means that short-haul flights within Europe can be alleviated, freeing up capacity. And you can connect directly with logistics centers, which means that you can connect, basically have centralize your warehousing, so you don't need to duplicate warehousing stock and processes all over the continent. So I want to very quickly show you a little bit about that idea of Hyperloop as a metro for Europe. This is what a station could look like. It's basically a station that has the same capacity as the entire airport of Schiphol, but it doesn't need all the runways. The way in which you exit and enter is very much like a metro. There's a door on both the vehicle and the infrastructure side with a seal that just allows you to enter. And because we don't have any windows, of course, we need to play with light to give a little bit of a sense of space. But as you can see, the experience is quite similar to what you're used to in existing modalities. And that's what it's in the end about. It's just a transport system. It's public transport, so it needs to be familiar. In our booth in 4.2, we have a mock-up of this experience. So you can also take a seat and see how comfortable it is. Now, the size of this station is quite limited in footprint compared to, for example, what an entire airport would be like. And I think that's in the end one of the biggest benefits of Hyperloop. These three infrastructures, road, rail, and Hyperloop, all provide about 16,000 passengers per hour per direction in capacity. But look at the difference in space that the Hyperloop takes. In the Netherlands, we have stopped building roads because of our nitrogen crisis. And we've been looking at those places where we were widening the roads. And actually, at the same time right now, there's a workshop in the Netherlands where they're looking at, can we maybe use those areas where we would widen the roads to instead build something that has exactly the same width, but provides about 6 times as much capacity. And if you can, that way, connect all the provinces in the Netherlands within about 15 to 30 minutes, you really have an attractive public transport system compared to roads, allowing that kind of modal shift. So the big vision, of course, in the end, is to build a network like this. This is like a metro in Europe. We have recently launched through the Hyperloop development program, Hyperconnected Europe, which is an initiative where we invite cities and regions to think along about what the Hyperloop network could be like. And where should we connect? Do we connect to the city center? Do we connect to the airport? Should we connect both? Maybe there's a bunch of more stops to connect regional locations. And the cities that you see here are parties that have already signed up and are working together with us to define those locations. I want to quickly take you through some of the numbers that we have simulated on this network. We've made a modal shift model based on existing transport planning standards that show that we could replace about 66% of short-haul flights, just competitively in terms of speed, and about 20% of long-distance trucking, which leads to an annual revenue of about 0.25 trillion, or 250 billion euros per year. The cost of a network like this, based on a study we also did with Deutsche Bahn Engineering Consulting for the cost of Hyperloop, will be somewhere around 1 trillion, including the fleet that you would need for it. So this is a ridiculously good business case, but you do need to have the entire network. So that's why I once again want to stress, we need to have one interoperable system, and that would also be one of my asks to the regulators and to the public parties, that this needs to be one of the requirements when basically procuring Hyperloop technology, that this is the way in which we need to have it. The CO2 reduction is about 133 to 242 million tons, based on no progress at all, versus following the electrification pathways of existing modalities. So it's also better compared to what we expect to have in the near future. Now this is the big vision. We have to start planning yesterday to build this, because it usually takes about 30 years to go from planning towards having something fully implemented. So it's good that all these cities are already working with us to plan out the locations, the dots and the lines. But of course we also have a few steps to actually get there, because the technology is not ready yet. As most of you know, we have this short test facility in Delft. We're moving it to Rotterdam now as we're moving there with our company. It's about 30 meters in length, but it does demonstrate levitation, propulsion, guidance, a lane switch within one tube, all in a low pressure environment. The big next step for us is that we really want to demonstrate that lane switch, that we can show that you can have vehicles merging out, merging in, which we really see as the core of the Hyperloop network. This is being built as we speak. The tubes are on their way with the steel supplied from our partners, Tata Steel and POSCO, who will also be presenting later today. And the goal is to have this up and running next year as a basis to really start developing the first potential routes. We've also already been looking at what could some next steps be in terms of technology development. Last week there was an agreement signed between the province of Groningen and the state of Niedersachsen. And as you can see, the facility that we're building in Groningen is very close to the existing Transrapid test line just across the border. Actually, that test facility is closer to the other test facility in Germany than it is to our office. And so you really see sort of a cluster happening there. And one of the things that we're looking at is it possible to, instead of demolishing the test facility, which will cost a lot of money, use that funding to revitalize the test facility, revitalize the region, and really build up a Hyperloop cluster there. And by the way, these are not Hardt test facilities. The center to which we're supplying is owned by an independent foundation. It's meant to be open, and I would expect the same for a facility like that to really set the European standard. So those are the steps that we believe need to be done in terms of development, and we hope to get started on building a first minimum viable route. So again, that's not a few hundred kilometers. That could be something like 3 to 8 kilometers connecting a city center to, for example, to an airport with a single tube, with a single vehicle, just showing that you have something that works where you can get in, you can get out, you can integrate it into existing modalities so that it builds up trust in the system, and that from then onwards, so that's why we need to start developing those routes now, from 2030 onward really starts building out the whole network. So once again, thank you all for being here and for the continuous support and the hard work continuously for the last 10 years already by anyone involved. And yeah, let's make it happen. That's the only thing I can say.
Thank you so much.